Hi everyone, this is our part 2 video for dimensional analysis. So in this we will be discussing the dimensional formulae for different physical quantities which you have already learned in previous years, like force, pressure, gravitational constant, then energies that like kinetic and potential energy, work, power, density, relative density, then a few electrical quantities such as electric charge, potential, resistance, resistivity and conductivity. Okay, so here we'll solve one by one. So before that, you may be remembering a few things what we have already learned in the previous video, like area, its dimension formula is L square, volume L cube, velocity Lt raised to minus 1 and acceleration is Lt raised to minus 2. So now we will start solving these practice questions. The first one is force. We will be doing that first. Force, we know it is m into A. So how we will write the dimensional formula for m? Capital letter M inside the square bracket, and we know acceleration is Lt raised to minus 2. Already in the first video we discussed. So for force, the dimensional formula will be, or dimensional equation will be, when we equate it becomes equation mLt raised to minus 2. Next is pressure. We know that pressure is equal to force divided by area. So we will do that. Pressure is force divided by area. I already written the dimensional formula for force. What is that? We already got that. mLt raised to minus 2 here. And area is L square. Area is L square. We know that. So now we don't keep anything in the denominator. So our dimensional formula will be L square is there. When it goes to up, it will become L raised to minus 2, and this is L raised to 1. So it will be L raised to minus 1 when you add, then T raised to minus 2 as it is. So M L raised to minus 1, T raised to minus 2 is the dimensional equation for pressure. Okay. Dimensional equation for pressure is M L raised to minus 1, T raised to minus 2. Third one is G. We know that that is universal gravitation constant. We know that F is equal to Gmm divided by D square. From this we can write G is equal to Fd square divided by M into M. So now we will write the dimensional formula for force. We now remember mLt raised to minus 2, that is for force, and for square of the distance L square divided by, there are 2m, so m raised to 2. Okay, so altogether when you take, it will be like m and m raised to minus 2. So it will be like m raised to minus 1. L into L square means it is L cube. Then t remains at t raised to minus 2. This is the dimensional equation for G. Now the next one is kinetic energy is half mv square. Constant, we cannot do anything. mv square, v is Lt raised to minus 1 the all square. So kinetic energy will be m L square t raised to minus 2. This is the dimensional formula for kinetic energy. Potential energy is the next one, the fifth practice question. So all energies should have same dimensional formula. For kinetic energy we got ml square t raised to minus 2. The same thing we should get for potential energy also. We'll just see, because both energy, all energy have same unit, so same dimensional formula also. If any two quantities shares the same unit, then their dimensional formula also will be same. Now we will check for mass m capital. G means acceleration due to gravity, so L t raised to minus 2. It's acceleration. H means it's a height, so L. So altogether how it comes? M L, how many L? 1 is there, 1 is there. So ml square t raised to minus 2. See, for potential energy we got ml square t raised to minus 2. For kinetic energy also we got. So ml square t raised to minus 2 is the dimension formula for energy. Sixth one is work. Work is force into displacement. Force we know that m l t raised to minus 2 and distance is L. So when you combine, it will be ml square, right? 2 L's are there. So ml square t raised to minus 2. Next is power. Power is equal to work by time. So now we already know the dimension formula for power. ml square t raised to minus 2 divided by t, time. So it will be like ml square t raised to minus 3. Because this t, when it comes to the numerator, it will be t minus 1. So t minus 2 into t minus 1 means what? T minus 2 plus 1. Means t raised to minus 2 plus minus 1. So minus 2 plus minus 1 means minus 3. Okay. Next is our 8th question. Mass by volume. What is that? Density. Density formula is mass by volume. So we can write m divided by volume. Dimensional formula is L cube. So it will be like m L raised to minus 3. 9th question is relative density. We know relative density is the ratio of density of a substance to density of water. So density of any substance, the dimension formula is ml raised to minus 3 divided by density of water ml raised to minus 3. So it cancels, we will be getting 1. So we can write, we can either tell it's a dimensionless quantity or m raised to 0, L raised to 0, T raised to 0. Now these are the last 5 physical quantities that is related to electricity. Now we will find out the dimension formula for these also. Charge Q, potential difference V, resistance R, resistivity rho, and conductivity sigma. Okay, we'll find it out. We know electrical charge is represented by the letter Q. So Q is equal to IT. Current into time is the formula. So we know I, current is a basic physical quantity and is represented by this dimension A. A for ampere and time T. So the dimensional formula is either AT, or you can write in this way also, that is m raised to 0, L raised to 0, T, A. T comes one time and A. This is the dimensional equation for electrical charge. 11th physical quantity we are going to try is electrical potential difference V. V, we know it is work by charge, work done per charge. So work, we already know the dimensional formula ml square t raised to minus 2. Okay, force is ml t raised to minus 2. So it's easy to remember in this way. Force is equal to ml t raised to minus 2. Work is equal to what? Work will be equal to ml square t raised to minus 2. Okay, so force is ml t raised to minus 2, work is ml square t raised to minus 2. So work formula we wrote already, divided by Q we already found. Q is equal to IT. So I means A and T means capital T. So we will be writing AT, isn't it? So we will write that divided by A into T. So when we write the formula, it will be looking like this for potential difference. ml square t raised to minus 3, A raised to minus 1. This is the formula for potential difference. Okay, this is the equation. Now ml square t raised to minus 3, A raised to minus 1. Next is resistance R. We all remember that Ohm's law triangle, isn't it? V equal to I into R. So R equal to V by I. So we can write R is equal to V by I. Now the dimensional formula for V we already found just now. What is that? V is W divided by Q. Work by charge ml square t raised to minus 2 divided by IT. So AT. So altogether we got in this way ml square t raised to minus 3 a raised to minus 1. That we will write here for V. ml square t raised to minus 3 a raised to minus 1. So that is divided by I. I means what? Current A. So it will be like ml square t raised to minus 3 a raised to minus 2. This is the 12th physical quantity, resistivity. We know resistivity rho is RA by L. Already we found resistance dimension formula R. So that as it is we will be writing ml square t raised to minus 3 a raised to minus 2 into A. A means area. So L square divided by L. So 1 L and L will cancel. So it will be like now M L square is there and but 1 L is also there. So ML cube t raised to minus 3 a raised to minus 2. This is the dimensional formula for resistivity. Next is conductivity, that is sigma or mho is the unit. So that is equal to 1 by resistivity. Okay, so resistivity we already got. So 1 by resistivity means resistivity as it is we will be writing 1 by that means it will be like m raised to minus 1 L raised to minus 3 t raised to minus 3 when it goes to up it will be plus 3 a raised to plus 2. This is the dimensional formula for conductivity. Okay, so we have learned dimensional formula for force, pressure, G, kinetic energy, potential energy, work, power, density, relative density, then some electrical quantities like charge, potential difference, resistance, resistivity and conductivity. Thank you.